Alright, there's a video for 3HT about exercise 38 and 39 of chapter 7. It says that Jason likes paragliding, because here he is, there she is. He's paragliding behind his boat. The cable between Jason and the boat is 45 meters, and the angle of elevation, so that would be the angle here, is 38 degrees. Now how high above the water is Jason? Now one thing that makes this exercise a tiny bit difficult is because there's 1.2 meters here, so actually the triangle that we have is a little bit above the water. Here you have 1.2 meters, so we're going to calculate what that is, and then we need to add 1.2 to it, and then we know how high that is. And this angle, so not till the water but till the line I just made, that angle is 38 degrees. Yes. We want to calculate this length, and if this is the angle, then this length is the opposite side. And we know the hypotenuse, and if you have opposite and hypotenuse, you use the sine. So that's what we're going to do. So I'm going to write down over here that the sine of 38 is the opposite side that we don't know, divided by the hypotenuse. So if you do the hypotenuse times the sine of 38, then we get 37.7, actually 27.7. And then we need to add 1.2 to it, so 27.7 plus 1.2 is 28.9 meters, so that's how high that person is. Alright, then we're going to go to question B. Now the boat speeds up. If the boat goes faster, then this person will also go higher, because of the pressure with the wind. So this causes Jason to climb another 9 meters. So this length, it was 27.7, but now in our new situation, right, here we have the triangle where the paraglider is. This length is still 1.2, but now this is 9 meters higher. That means that this is 36.7. Well, this is also still 45 because the rope stays the same length. And now we have to calculate what is the new angle of elevation. So we need to calculate this angle. So we're going to use the sine for that. So I'm going to use sine. If you calculate an angle, you use -1. Now the opposite side is 36.7 and the hypotenuse is 45. So if you calculate this, then we will get 54.7 degrees, and that's the answer. Then we're going to go to exercise 39. It says here, figure 7.43 shows a giant swing with some people on it that are swinging. First question is, how high above the ground is the swing when the angle of deviation there, now they call it an angle of deviation, I'll explain it in a moment, is 50 degrees. I mean, elevation means, hey, now my pen is flat on the table, and now it's elevated, so then you have an angle of elevation. But this is not really elevated, because this is vertical, so then it's called an angle of deviation, because now it's like exactly that, and it differs a little. It's called the angle of deviation. You don't really have to know that word for a test or anything. But you can see here, this angle is 50 degrees, and what we want to know is, we want to know how high is the swing above the ground. So what is this? Yeah, we already know the total length is 3.05. So if we calculate what this length is from here to there, we can do 3.05 minus that length, and then we have that length. So we're going to use this angle, and this is the adjacent side. So we're going to calculate the adjacent side, and we know the hypotenuse. Adjacent and hypotenuse, that was the cosine. So I'm going to write down over here the cosine of 50 equals the adjacent side, which we don't know, divided by 2.45. So then if I calculate what the question mark is, 2.45 times the cosine of 50, so let me type that into my calculator real quick, times the cosine of 50, we get 1.57. So if you want to know how high this is, we do 305, which is the total length, minus 1.57, and then you have the answer. Alright, so this will be, let me see, 3.05 minus 1.57 is 1.48. That's how big the, how high above the ground the swing is. Then exercise B, the maximum height of the swing is 205 centimeters. Right, so what is the corresponding angle of deviation then? So we have a new situation. Here's the pole that we see there. Right, here's the swing, and now the height of the swing is 2.05 meters. the swing is connected to this pole there, and this is the angle of deviation, so that's the angle that we want to know. Now we do know that this is 2.45 because that length doesn't change, right? If it just moves back and forth, that length doesn't change. There's another length that we know because the whole length is 305, right? So that means that now it's 1 meter because this height is 2.05, so it means we have 1 meter left. And then we want to calculate that angle. So we're going to use the cosine. Because we calculate an angle, it's the cosine minus 1. And then it's the adjacent side divided by the hypotenuse. Alright, so let's calculate what we will get. Cosine minus 1, 1 divided by 2.45, and then the angle is 65.9 degrees. So here you have 65.9 degrees. And that's the answer for 39b. So thank you for watching. Bye bye.